Number 82. In dilute aqueous solutions, HF acts as a weak acid. However, pure liquid HF, which has a boiling point of 19.5 degrees Celsius, is a strong acid. In liquid HF, HNO3 acts like a base and accepts protons. The acidity of liquid HF can be increased by adding one of several inorganic fluorides that are Lewis acids and accept F- ions, for example, BF3 or SBF5. Write balanced chemical equations for the reaction of pure HNO3 with pure HF and of pure HF with BF3. Okay, so we just have to write two different balanced equations here. The first one is what's going to happen when you have HNO3 mixed with pure HF. So let's start with that one, shall we? Doesn't matter which one you put as, the first or the second one on the reactant side, but we do know that HNO3, and maybe I'll make this a little bit bigger, HNO3 is going to be added with HF. Now, they did say that we're using HF as pure HF. And they said that pure liquid HF, wait a minute, here we go. Pure liquid HF is a strong acid. So that means that HF is going to act as the acid because we are in the pure form. So maybe I'll write that one down as a red for acid. And then they say again that in this liquid HF, which is the pure HF, HNO3 is the base. So in this case, HNO3 usually acts as an acid, but in this case, it's a base. So let's just find out what happens. Now, this is just going back to the acid-base chapter, right? Remember, acids always donate their hydrogens, aka a proton. Whenever you see the word proton, this just means the H pluses, right? H plus. So the acid will donate its hydrogen. That's the proton. So the H goes with the base. So if you get rid of that H, you're only left with F minus. Now, why do I know it's minus? Is because when you get rid of an H, you always go down in a number. You minus 1. So since there was no charge here in the upper right-hand corner, that's neutral, that's 0. So 0 minus 1 would be a -1. Now, we just have to add the hydrogen to the HNO3. And you won't have one H anymore. You picked up another one. So this would be H2NO3. And now, just charges. If you're gaining a proton, you plus 1. So if you lose a proton, you minus 1. If you gain a proton, you add 1. There was no charge in the upper right-hand corner here, so that's 0. So 0 plus 1 is just a plus 1. So you could just say plus. That's fine with me. Here is your first equation. Okay, now we just have to do the other one. Let's see. Now we need to react pure HF with BF3. So I'm doing it again. I'm going to say HF plus BF3. But now we got to figure out, well, what's going on here? Let's see. Where in the reading did it tell us? So it says the acidity of that pure liquid HF can be increased by adding one of the several inorganic fluorides that are Lewis acids. And the Lewis acids are going to accept that F minus ion. Okay. And they're saying that, for example, that BF3, that's going to be the Lewis acid. So in this case, BF3 is going to act as the Lewis acid. Now, when we talked about acids and bases before, these were Bronsted-Lowry. So maybe I'll say BL, Bronsted-Lowry acid, Bronsted-Lowry base. In this case, we're now switching over to Lewis. Just, 3 different scientists, 3 different chemists, right? Bronsted, Lowry, and you got Lewis. It's the same Lewis as the one that, has the Lewis structures. It's the same Lewis. Guess he was doing a lot back in the day. Guess he never really got out much. Oh, man, I cracked myself up. Okay, anyway. So we have Lewis acid and a Lewis base. Okay, so remember, Lewis bases will donate electrons to the Lewis acid. And the Lewis acid, they said, will accept F- ions. And where's the F- going to come from? It comes from the base. Keep in mind that this HF is broken down into two components. It has H plus and F minus. If we, got rid of the compound and we just found out what the plus charge and the minus charge was. This is what's going to be going with the Lewis acid. So you're increasing your fluorine by 1. So you won't have 3 fluorine anymore. You'll have 4. And the charge has to go with it. If you have a minus here and you're adding it to this, you still are negative, right? Because this BF3 didn't have a charge in the upper right-hand corner. So this has to be BF4 minus plus, well, what's the only thing that's left from your HF? If the fluorine went, you only have H plus left. So that would be just H plus. And those are your two formulas. If you have to put the states, go and put the states. But for this case, they didn't say, so we just have that balanced chemical equation, so we're good to go. All right. I really hope this helped you out. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out, and I hope you guys are having a great day out there. I will talk to you soon. Okay, bye-bye.